Alright, hello everybody. This is my physics summative for SPH3U, this year's course for physics. I'm going to grab it here. Perfect. So as you can see here, this is my pinhole camera made out of a wooden box, a lot of dowels, some foam, and an old can that I had. I'll just take you around the camera to start. So as we open it up here, you'll see the various different components. We have the lens, the exposing chamber, which has the 36 by 24 exposing hole in it to fit 35mm film. As you can see, the track here is designed to fit 35mm of height, which is why 35mm film is called 35mm film. On this side, we have an advancing reel. The film just tucks into this little slot here, and I'm able to turn it around one time completely to get to the next exposure. That'll leave me enough room in between two exposures. And we also have the rewind dowel as well, for when we need to rewind the film without using the darkroom. On the front of the camera, we also have our little shutter here, just slides in and out, and some foam just to hold it down and make sure everything's all right and in place, and just make sure that we don't have much light pollution in general. So that's basically around the camera. Now we have to get into the more difficult part of explaining everything behind it, and I'm just going to get my papers out here so I know what I'm doing. Perfect. So physics. Everything in photography is controlled by a type of science called optics. And I'm sure we all know that. It's how we see everything. It's basically the science of how light reflects off of objects and how we perceive it. So I'll draw you a diagram of exactly how this camera works. And it all has to do with the pinhole and the light being reflected off an object. So the sun, rays of light come down, and of course in waveforms, and those wavelengths, of course, lambda, they hit a lovely object. For example, this tree here. That's a very well drawn tree. Anyway, it hits the object and then goes into the pinhole and exposes the film, which we will also talk a little bit about later. But I'll just explain how the pinhole works exactly before we get any further. So we'll say that this is the lens, the pinhole being right here. This is the film. So light is reflected off the tree. Comes through the pinhole. When of course the shutter is opened and exposes the film. But you'll notice here that there's a little bit of a gap in between the two rays of light. What we really want is the focal length of the lens, or the end of the lens where the pinhole is, should really be right here where the two lines meet so that we get the right image. Right now it's not, which means that we could get images, double images or triple images or how many other images, because rays of light like this are going to be showing through as well. So we're going to see something maybe a little bit fuzzier, like a little halo around the tree. And it does happen, it's just a fact of life. But really we need to get the pinhole to the right size to do this. And there's a simple equation to do it. It's not that hard to follow. It's optimal diameter of the pinhole is equal to 2f wavelength. And the wavelength of light that we want is 0.007 millimeters, and that'll cover the broadest range of colors, since every color has a different sort of wavelength to it. So our focal length on this camera was 90 millimeters. times 0.0007, and that would get us to just about 0.4 millimeters. So my pinhole was actually 0.7 millimeters, so we are going to see those fuzzy images that we didn't want to see, but we have to see anyway, which is not bad, but not good at the same time, because we're somewhat close, but almost double the optimal diameter, which is not the best for that. Just really quickly, I forgot to point something out when I was originally talking about this, but as you can see, the light traveling off the tree is coming off so that it's exposing actually to make a weird upside down image rather than that's a horrible double image, but than what we actually see. So when they're processing the film, it doesn't really matter, because we can just take this, say this is the upside down image, we'll take it, flip it around, and it'll be perfectly fine at the end. But it is really important to know that when film exposes, it is an opposite image of what you're actually seeing. It just flipped upside down. Another thing I just forgot to mention, so depending on the lenses that you have, the focal length, you can actually get it to be a little bit closer zoom or further away. So as you can see, I'll just draw a few other ones. This is what we call wide angle and telephoto lenses. So let's say that the pinhole is just right there. So as you can see, the light coming in is coming in from much a wider angle. So we can capture the tree, maybe some people playing around it, I don't know. Yeah, but with this lens, we're gonna see a lot less. This was not well drawn, unfortunately, but we'll be able to zoom in a lot closer and see a lot less of the actual shot. So maybe this is the right type of lens for that leaf that you want to zoom in on the tree, or anything up close. Say you just want this guy's head. That's the type of lens you'd probably be using for it. So yeah, that's basically all you need to know about pinhole lenses. So when we talk about film that's inside here, the exposing chamber, it's extremely photosensitive, which means that it's sensitive to the photons of light that are coming from the sun. And these reflected photons are going to come onto the film, depending on if it's black and white or color negative film, produce a black and white or color image. I was using color film. You'll see that in a bit, but basically what they do is the photons hit and almost absorb into the film. So if we just open up a strip of film right here, it's going to be super exposed because there's so much other light source, which is why it's very important to have this box completely dark on the inside, so that we don't have any extra light coming into the exposure chamber other than the light that's coming from the pinhole right here, and no extra light hitting the film that's already been exposed on the reel here because it's not protected. So as a precaution, as you know, these wooden boxes don't close all the way. So I put electrical tape, just regular black electrical tape, on the camera's rim here, just to make sure that there weren't any light sources coming in and accidentally overexposing the film or double exposing it, which would be very interesting to see in the images. And there's also foam and painted hot blue there, just to protect the interior from any light coming in from maybe a little bit of a gap between the can and the wood of the box. So that's basically what you need to know. But now we're going to talk a little bit about exposing the images. To expose the images, I've already said that, pull out the shutter, push it in. But we need to know what time it is. So what time, how much time we have to leave the shutter open. Now, usually your camera, like the one I'm using now, will do this for you automatically. But this one, wooden box technology, hasn't really gotten that far yet. So we need to figure out the right aperture for that to get the right shutter speed. And the way we do this is we need to set our camera, or our light meter, I used my camera in this instance, to a certain aperture, and then find how many, the ratio in between the camera's aperture and the pinhole camera's aperture. So that's pretty easy to do. This will find us our exposure factor. So the equation is the f grade of the pinhole over the f grade of the camera squared. But what's the f grade? So the f grade is basically a number describing the amount of light coming into the camera through the pinhole. To find this, I'll just put FG here. It's pretty simple. It is the f number is equal to focal length over diameter, both in millimeters. Very important unit in photography, as you probably already know. So we got 90 millimeters, 0.7 millimeters, which gives us an f number of 129. And since the units cancel out, it's really just a reference number, not an actual real number. So now we can use this to plug it into our exposure factor equation. So we're going to do 129 over 22 is what I have my camera set at, squared. That'll get us to 34.4 times. So that's our exposure factor. And what we do with this is we have to multiply what the shutter speed shown on the camera up here that actually has a light meter in it, 34.4 times to get the right exposure for this. So to do this, we're just going to multiply the exposure factor by the shutter speed on the camera. So we'll do 34.4 times, let's say it's 1/60th of a second, which is actually what I had for some of my shots. That'll come out to about 0.57333333 seconds. So as you can see, it's a relatively small number, so it's hard to calculate exactly how to do that. It's hard to even time it right. So we're probably going to get overexposed or underexposed shots, since there's no way we can actually just open and close it automatically. So again, timing that's going to be hard, but then again, oh well. So let's get a few examples here. I just got these back yesterday. So I marked, I'll show you the first few that it actually turned out. This is a little ball lantern. I marked it with 1EX on the back, so if you want to take that out and look at it. It basically actually turned out pretty well. It's a little fuzzy, which is what we expected because the pinhole wasn't the optimal diameter. However, we can still see the image. There's colors showing, there's things in the back, more ball lanterns. You can see the cables that they're attached to. You can easily see the rings of them. It's like a Chinese lantern almost. So that's pretty cool. Turned out well. Next, I want to show you this plush penguin. So as you can see, there's little light, I don't even know what to call them. Call them light shreds coming in. That's just light pollution, and as we already talked about, double exposed the film, unfortunately, and we didn't get the clearest picture that we wanted. But you can still see that there is a penguin there. It is marked as EX2 on the back. If you want to take a look, I'll do that now. Yeah, so that one actually turned out well as well. Some hardwood, of course, and a picture of the window in my upstairs. That actually turned out well too. You can see the window pane, some of the curtains, house across the street, bushes, trees, all sorts of stuff. Now we get into the weird ones, and these ones didn't turn out because this one was underexposed. I can't see anything, it's way too dark. This one, I think I just shook too much because I can see that there's objects here in the background. I'll mark these EX3 and 4. But anyway, yeah, so it's harder to see. I was either holding it too much, shaking it, or this one was underexposed. Try and find one that's overexposed. Here's a good example. I don't even know what it is. There's nothing that we can see, which means that too much light hit it and eventually caused us to have a bad image, and this will be EX5. So as you can see, I had some success, some failures throughout the experiment. And of course it's going to happen. It's my first time ever building a pinhole camera with film in it, and my first time ever using film actually. So I really hope you guys enjoyed as much as I did. It's kind of an interesting science optics and how it works, but it's a hard one to control, almost impossible. But with a few equations, we'll have everything we need to know. And with that, thanks for watching. I'm guessing I'll be doing this again in the future. I just got a film camera, so I'm super excited to use that. And I'll probably try making some improvements on that to make sure everything's right for next time. But until then, thanks for watching. Since you can't see them very well in the video, I decided to scan the photos just so you can have a better look at them. So without further ado, here they are.